All right, so for number 2 on the projectile motion worksheet, we are going to take a look at where these numbers are coming from and what they mean and how to do tricky problems like this where you don't know the initial velocity. And they're a little bit interesting because you have to do a systems of equations. All right, so the distance she jumped is 3.5 meters. And we also know the initial angle was 40 degrees. So what we're going to do is we're going to draw a triangle to show her starting velocity. We don't know what it is, so we're going to call it V naught. And in the y direction, we don't know what that is, but what we can do is make an expression for it. And how we're going to do that is we're going to remember that this angle here is 40 degrees, and we were given that here. And it says relative to the horizontal. And then we also don't know V naught x, but again, we're going to be able to find an expression for that. So V naught y is opposite, so we're going to use sine of our 40 degrees is opposite over hypotenuse, so that'd be V naught y over V naught. And then what we're going to do is we're going to move this V naught to the other side by multiplying both sides by V naught. And so I'm going to get V naught y is V naught times sine of 40. And then I can do the same thing for my V naught x. But now I need to do cosine because cosine is adjacent over hypotenuse. Again, I'm going to multiply both sides by V naught. That's going to get this V naught to cancel out. And then I have V naught x is equal to V naught times cosine of 40 degrees. So now I have an expression for the x and y directions. And now what I'm going to do is I'm going to do an equation for the x direction and an equation for the y direction. And we're going to see which one we can solve for something, probably time, to be able to then solve for the other thing. So I'm going to start by plugging in the numbers here for the x direction. So in the x direction, my final position is 3.5. My starting position was 0, because if I'm going to measure the length of something, I'm going to start at 0. Instead of V naught x, though, we're going to put this thing over here that we just found for V naught x. And then we can't forget about this times time part, so don't forget about that, times time. Plus, and then my acceleration in the x direction is 0 because nothing is pushing it left or right. So if you don't have anything pushing or pulling on it, it's going to keep going at the same speed. So 1/2 times an acceleration of 0 times time, well, all of that then will be 0. So I can just go times 0, or plus 0, sorry. Then what I'm going to do is I am going to rewrite this. And I'm going to put all the numbers in for the y direction. Again, instead of V naught y, I'm going to put this V naught times sine of 40 because that's the expression for V naught y. So this is going to go right there for V naught y. And then again, don't forget to multiply times t. All right, so at this point, I have 2 equations and 2 unknowns. I don't know V naught and I don't know time. So I don't know my overall starting velocity and I don't know time. So the reason why I put these in terms of V naught meant that I got rid of V naught y and V naught x. So instead of 2 variables, one being V naught x and one being V naught y, I was able to get it down to just one variable that I didn't know, which is my overall starting velocity, which is V naught. Now I need to eliminate a second variable because these both have a V naught and a time in the equation. Unfortunately, this y direction also has a time squared, which is annoying. So what I'm going to do is I'm going to take my x direction and solve for starting velocity. I'm going to solve for V naught because I don't want to solve for t, because if I solve this for t and I get t is equal to some stuff, then when I plug it into this, I'm going to have it here, and I'm going to have to square it. And that's gross. I don't want to square anything. So instead, what I'm going to do is I'm going to rearrange this equation so I get V naught by itself. So the way I'm going to do that is I'm going to just divide everything by cosine of 40 times time. All right, so I move the cosine of 40 times time to the other side by dividing by both. And now I have an expression for my starting velocity. So now instead of V naught, I'm going to write all of this stuff. And that's going to go in here where this V naught is. So now I'm going to go ahead and rewrite that. All right, so I put in something for V naught. The sine of 40 stayed and the time stayed. Make sure you're not losing random things. And then one thing I want to point out is this time is on the bottom, this time is on the top. So these are going to cancel each other out. And what I'm going to do is I'm going to multiply the 3.5 times sine of 40 divided by cosine of 40, and I'm going to get a number. And then I'm going to do 1/2 times negative 9.8, and I'm going to get another number here. So I'm going to get one number for all of this and another number for that. All right, so then if I just subtract the 2.9368 from both sides, and when I do that, I get this, and then I'm going to divide both sides by the negative 4.9. So I'm not subtracting, I'm dividing. And then I square root both sides. All right, and now I have time. And what I'm going to do is I'm going to take this time and I'm going to plug it back in to this equation up here, because this equation, if I have time, then I can solve for my starting velocity. And just to be sure, make sure you put everything in the denominator or the bottom. Make sure this is in parentheses when you type it in your calculator, otherwise you will not get the right answer, because it'll divide by cosine of 40 and multiply divided by, it'll divide by cosine of 40 and multiply times 0.774 instead of dividing by both. So what I get is I get a starting velocity of 5.9016. So I'm going to just leave it as 5.90 meters per second is my starting velocity. Let me know if you have any questions.